So good evening. My name is Atsushi Takai, Associate Professor of Kyoto University. So it's really great honor to be here to explain about management and utilization of disaster waste today. I'm sorry, I mistyped my title in the program, and I think there was a M here. So it was management of disaster waste management. So I'm sorry, it's a mistake. Management and utilization of disaster waste. Okay, so I received a lot of support from Dr. Otsuka. He is director of Okumura Corporation. Okumura Corporation is one of construction companies in Japan, and he was involved in disaster waste management in 2011 East Japan Great Earthquake. Okay, so today a lot of students from Kyoto University also joined. I really appreciate your support. And so I'd like to accept your questions anytime, but please send a text from that Q&A function. So if you have any questions, please type your questions, and I will pick up your questions as much as possible after my talk. Okay, so let's start. Okay, so my name is Atsushi Takai. I got PhD in global environmental studies, but my background is civil engineering. Do you know civil engineering? It's kind of construction for public. So yeah, this is civil engineering. So my major, civil engineering is really wide. It deals with a lot of fields, river, bridge, dam, etc. But my major is soil. So yeah, I have 10-year research experience in utilization of disaster waste, but especially from the viewpoints of soil. I will explain later about why I was involved in disaster waste management, although my major is soil. And Dr. Otsuka, he also graduated the same laboratory, and yeah, his major is also civil engineering, and I have a really deep connection with him, and I have a lot of research projects with him, and he has 30-year work experience for waste management, including disaster waste, and he was involved in disaster waste treatment and management during 2011 Great East Japan Earthquake. So today's aim and scope of this session is as follows. So I'd like you to understand the role of waste landfills in disaster waste management, and understanding the recommended items for separation of disaster waste. And as a third item, please understand transport plan, transport scheme of disaster waste management. So first, I'd like to explain what the differences of disaster waste and ordinary waste. There are many categories and definitions of disaster waste, and this is one of such category. By evacuation activities, this evacuation activity also generates a lot of waste, and it's also counted as part of disaster waste. For example, general waste from excavation centers and medical waste from medical centers. So they are also part of disaster waste. And by earthquake, by earthquake, there are three typical wastes. One is household furnishing and belongings. And of course, houses a lot of houses are collapsed by earthquake. So those demolition waste are also generated. And cars and vehicles are also generated as waste. So we need to dispose, we need to treat this kind of waste by earthquake. But when the tsunami also occurs, there are many ways. There are many ways are generated, including the same categories, same goods. For example, furniture, household goods, and houses collapsed. But in addition to these items, tsunami sediment, fisheries, or large waste, concrete aggregates, wood, etc., are also generated. So a lot of various waste are generated when tsunami occurs. So these are kind of category. So you can see they are really clearly defined, and it looks like these waste can be generated separately. But the actual state is totally different. So for example, this is a state of disaster waste. Various wastes are mixed and need to be separated for appropriate disposal. So you can see from this photo, this e-waste and tires or stoves or furnitures, they are mixed together. So, but we need to consider to recycle disaster waste as much as possible. I will explain later why this separation is necessary. Yeah, and this is some examples of mixed waste, mixed disaster waste. And yeah, so yeah, of course, it's really important to remove waste from affected areas, from damaged areas as soon as possible, because we need to reconstruct such affected areas. So the removal of waste is really important, and it has to be done quickly. So to do so, of course, it's really difficult to collect, for example, only wood, only metals, only plastics, etc. So it's very easy and fast to collapse and everything and deliver everything to storage site. It's, of course, it's very faster. But when those mixtures accumulated and piled in one place, for example, you can see here, it's firing. So fires occurs because organic matters are included in those mixed waste. So because of this organic matters, fires also occurs. So it's really dangerous. So it should be avoided. So the separation is really important. Actually, until yesterday, I went to Kumamoto. Kumamoto was affected by heavy rain in last July, and flooding occurred, and flooding of river occurred, and some river sediments were deposited in houses because such river flooding excavate the riverbed, and it deliver a lot of soil from the riverbed, and such sediments deposit on land. And so the government asked residents to deliver on the soil, on the wood, on the plastic, etc. So this is one of piles of soil. But you can see there are a lot of woods and it's not pure soil. So if we use this kind of soil containing woods or other waste, such structures, for example, embankment or the other structures, is not too strong enough. So it can become very weak if the organic matters disappear with a long term. So separation is really important. So yeah, this is really natural idea, and I think it's really simple. And waste when mixed, so but resource when separated. So if we separate everything, those mixed waste, each materials can be recovered as material, as resource. So we need to try to do best effort to separate those mixed condition of disaster waste as much as possible. I think this is really a basic concept for ordinary waste, but this idea should be applied also for disaster waste. So yeah, I explained the waste, disaster waste are removed from affected areas immediately after the disasters. So after removal of those wastes, waste has to be stocked in a certain place. So I think you have heard this term, temporary storage site, but I'd like to explain what are the requirements for temporary storage site, TSS. But tomorrow you will learn more details about temporary storage sites, TSS. So I briefly explain about TSS. So yeah, about definition of temporary storage site. So temporary storage site, TSS, is a place to temporarily store disaster wastes before they are treated or disposed of at treatment plants and or landfills. So you can see this figure. So after removal from affected sites, those wastes are collected and delivered into this temporary storage site. And in this temporary storage sites, those disaster waste of mixed condition is stored and separated in this temporary storage site. And after treatment and separation, each material, each waste disposed or reused or recycled. So this kind of place is really important to handle such disaster waste of such a large amount. But why do we need temporary storage site? Yeah, I explained that to enhance the efficiency of disaster waste transportation, for better reconstruction works of affected areas, we need to gather those disaster waste in a certain place. And we need to remove disaster waste from affected sites as much as possible. So this kind of temporary storage sites is really necessary. And also to allow separation and enhance reuse and recycling. Yeah, this is also the really important issue. And to reuse and recycle, to utilize those disaster waste, separation is really important. So to do such separation works, temporary storage sites is really necessary. So I explained the necessity of temporary storage site. So what would be the requirements of the such temporary storage sites? There are many requirements for temporary storage sites, but I think there are two main reasons, two main requirements for temporary storage site. First one is easy to access from affected sites, but not too close to residential areas. Yeah, so because a lot of disaster waste has to be delivered into temporary storage sites. So if the temporary storage sites is too far from the affected sites, it takes time, it costs a lot, so it's not effective. So it should be close to affected areas. And especially when the disaster waste become a problem, disaster waste should be generated in downtown areas, basically. So those disaster waste are generated if it's in a, for example, forest or very countryside where nobody lives. I think some guys may leave those disaster waste for a while. So when we have to hurry up disaster waste treatment, the disaster should occur in downtown area, and we have to remove those waste as soon as possible. So the disaster waste, the temporary storage site should be close to affected sites, but not too close to residential areas, because a lot of dust are also generated, and it's also noisy to treat disaster waste, and it may smell. So it should not be too close to residential areas. The second item is vacant enough to treat a large amount of waste. Yeah, as I explained previously, a lot of disaster waste are generated. So the temporary storage site should be vacant, should be large enough to treat those waste. So as one of options for such temporary storage site, waste landfills can be used, because the waste landfills should be constructed with the same concept, with a similar concept, because the ordinary waste are also generated mainly in downtown areas. So it should be not too far from downtown areas. And it should be not too close to residential areas. And the landfills should have enough space. It should be large enough. So the one of option as a temporary storage site is waste landfills. Yeah, so this is a quick review of the knowledge about the temporary storage site and waste landfills. So the space for separation, which can accelerate recycling, is really a good aspect of waste landfills. So again, waste without separation, but resource after separation. So the landfills, waste landfills, can ensure that enough space for separation works. So I explained that separation is really important, but of course we cannot achieve 100% of recycling, and some waste should be remained as waste, and we have to dispose those waste into waste landfills. So if we conduct such separation works in waste landfills, of course it's very easy to dispose into landfills. So it can accelerate the disaster waste management. So yeah, I think the amount of waste disposed into landfills may change, may be various according to the type of disasters or the magnitude of the disasters, but we always need to ensure the enough remaining landfill capacity, always. Okay, so I'd like to give you, today I'd like to give you 2 quizzes. So one is this one. I'd like to think about necessary tools, equipment, and machines for disaster waste treatment together with you. I showed you this figure previously. So we need to collect disaster waste from affected sites, and we need to deliver those waste into temporary storage site. And in temporary storage sites, we need to conduct separation works, and of course we have to store for a while. So let's think what will be necessary for this disaster waste treatment. So as a first one, for this cleaning and collection at affected areas, not in temporary storage site, affected area, what will be necessary to cleaning and collecting those disaster waste. And second one is storage and separation should be done in temporary storage sites. So in temporary storage sites, what will be necessary to conduct this temporary storage and separation works? I'd like to give you 1 minute to think about the necessary tools and items or equipment. First, about cleaning and collection. Okay, so please think for 1 minute. There should be various tools and equipment. But if it's really difficult for you to think, I give you 1 hint. These are just examples of my idea, but I could categorize into 2. And first one is personal equipment and tools and machines. What would be possible items, necessary items for cleaning and collection?
Yes, can we start answering?
Yes.
Yes, for personal equipment, I would select helmet, gloves. Generally, all the PPEs are necessary, and also masks sometimes.
Yes, you're right. Anybody else? Yeah. Do you have any?
Tools and machines, maybe loader truck. Loader truck is necessary.
Only truck?
Loader truck and also collection truck.
Yeah, okay. So I show you some examples as Gabriel-san explained. Yeah, those personal equipments are, general personal equipments are of course necessary. But in addition to those ordinary items, I think this is also kind of ordinary items. But because a lot of waste are collapsed and there are a lot of sharp items, sharp waste, so safety shoes should be equipped to do the removal works in affected areas. Do you know these safety shoes? Okay, so iron plate is installed in shoes, so it can avoid puncturing your foot. Okay, and yeah, the dust mask is really important because it's really dusty, Yeah. And as tools and machines, I think this is really typical and a conventional item. So any country should have this equipment. So this kind of very simple equipment can also help the removal of disaster waste. Wheelbarrows, and this kind of bulldozer or wheel loader, this kind of heavy machine is also important. An excavator is just a shovel, power shovel, but this is a kind of special bucket, and it can be used as a sieve. So it can collect only large items. If necessary, this kind of bucket is also important. Yeah, and of course, dump truck is necessary to deliver from affected sites to temporary storage sites. Okay, so how about the necessary items for storage and separation? So I give you 1 minute again to think about the for this phase.
Professor, I have one question about that. Could you give us some hint about what is separation in here?
Okay. So separation means the separating mixed waste into each fraction. For example, metal, wood, soil, plastic, etc. But this separation works consists of very basic processes, and this separation works consists mainly of crushing and sieving. Do you know sieving? Sieving is to remove small fractions, tiny fractions. It's using mesh. Okay, so separation works crushing and sieving.
Thank you so much. Understand now.
Okay. Do you have any opinions or answers for this?
Yes. Can I answer?
Yes, please.
I think it needs to move screen or dump car or something to separate and storage, I think.
Yes, exactly. What else?
I can give answer.
Yes.
Some machine that we can use in the storage and the separation, I think is a crusher, steel plate. We can use in this item.
Yes. Thank you. Thank you for your answering. Yes, as general equipment, as you said, steel plate is really necessary because some grounds are really muddy and it cannot support the heavy machines for separation works. So to realize the effective separation works, this kind of steel plate is necessary. And high pressure jet is also necessary. I don't know if all the countries have this kind of jet, but this is, it's really simple, but it's just a jet to remove soils from tires. Because if we don't use this high pressure jet, the trucks and dump trucks will deliver soils with those tires, and it will distribute a lot of soils around the temporary storage sites. So in Japan, not only for disaster waste management, also in ordinary waste management, we always use this kind of high pressure jet to remove the soils on tires. before they goes out from the site. So this kind of high pressure jet is also necessary. Yes, and I explained that separation works consist of crushing process and sieving process. So this kind of crusher is also necessary. But I think this kind of, any countries should have this kind of similar equipment for crushing some materials. Also for rocks or mining or such activities. It's very simple. It just crush large fractions into small pieces. So this crushing process is important because for screening, this is screen. There are some different types of screen. This is a rotating screen. So it can rotate and it's inclined a little bit. And during the passing through the screen, the small fractions can be extracted and only large fractions remain on the screen. And this is a different type of screen. This is just a vibrating screen, but this screen is also inclined. So the waste can goes to the next step. But to use this kind of screen, we have to crush large fractions into small pieces. So that's why this crushing process and sieving process main part of separation works. And of course, dump trucks are necessary to deliver. So these are really fundamental and basic items, but I think you could recognize that separation works can be done with very, very basic and simple equipment. So I think that's a really important knowledge. And yeah, separation works sounds a little bit difficult or a little bit advanced, but they are not too advanced, and it's really a simple method. So I think in any countries, separation works can be done using conventional and typical equipment. So I'd like to introduce some, not some, only one case study in Japan, separation of disaster waste in 2011 Great East Japan earthquake. So in 2011, as you know, the Great East Japan earthquake occurred. So, and a lot of disaster waste are generated, and the basic concept of disaster waste management in this disaster was to preserve the living environment of residents and fast and proper recovery from disaster. But we also need to achieve reduction in waste disposal. So we had to separate and utilize disaster waste as much as possible. So you can see these photos, and they are really mixture of various materials. So yeah, it was really a large amount, 30 million ton of disaster waste was generated. And yeah, disaster waste treatment was completed. It has to be completed within 3 years in most places. In most places means Fukushima prefecture was a little bit special. So in Fukushima, we couldn't complete waste treatment within 3 years. But in other parts, we could finish the disaster waste treatment within 3 years. And one third of this 30 million ton was soil, so large soil fractions. You can see dark brown color here, it's basically of soil. So you can see that there are many soils contained. So we tried best effort to extract soils from disaster waste, and we tried to use such recovered soils in reconstruction works. But it was really challenging. So it was really difficult. But anyway, we had to try to utilize all the disaster waste as much as possible. Yeah, again, so it was really a large amount, and disaster waste generated in this earthquake corresponded to 10 or 20 years annual waste generations in local municipalities. So if we dispose everything into landfills, of course, landfills can be full easily. So landfilling was not preferable. And not only for such capacity lands reclaimed with the organic rich materials is not stable, and it generates gas, toxic leachate, and bad odor. In addition, I explained at the beginning, unexpected fires also occur due to such organic matters. So we had to avoid landfilling of all the waste, and we had to utilize disaster waste as much as possible. So the separation and recycling was preferable. So yeah, there are some reasons for the separation, the necessity of separation, but I think you can easily imagine that why separation is important. So this is a basic flow of disaster waste treatment in 2011, Great East Japan earthquake. And this basic flow is same with the basic flow I showed you previously. So first, collected and transported to temporary storage site. But in this earthquake, some temporary storage sites were prepared. And in the first temporary storage sites, we conducted rough separation. Rough separation. It's kind of pre-treatment before the real separation works. But rough separation was conducted using these kind of heavy machines. And the disaster waste after this rough separation was transported to the second temporary storage site. And in this site, you can see this is a big factory, but this is temporary factory, not factory, but temporary facility. And this is a waste treatment system. And in this site, advanced separation was conducted. I explained advanced separation was conducted in this site, but not only in one site. This kind of facility was installed in each local municipality. So they used various types of this kind of separation system. But basically, again, this system consists of crushing and screening. And disaster waste treatment was completed within 3 years in most places. And with this advanced separation or this rough separation, we could obtain this kind of separated fractions of metals, wood chips, crushed concretes, hazardous materials, soils, etc. So after separating to each items, we could recycle, we could utilize, or we could use some soils and wood chips in cement production or incineration and landfills. So we could choose the best option for each material. But if we didn't separate those disaster waste. We had to dispose everything into waste landfills. These are some examples of disaster waste treatment system. You can see this is really a big factory, but this is just a temporary system. And it was constructed and demolished after 3 years. So yeah, this was installed in Ishinomaki. And this is an incineration. So this is also temporary facility, but this was installed only for this disaster waste management. And sometimes this kind of manual separation by hand was also conducted. So by using these kind of various techniques, we could obtain plastics, wood, metal, concrete, residues. Residues means soil with some waste, because it's really difficult to collect, extract only soils, because very tiny pieces of waste are also, it can pass through the sieving. So it's very difficult to collect only soils. So small wastes are also contained. So we call it residue. So, but anyway, by separating the disaster waste into these categories, into these materials, we could achieve recycling of 80%, more than 80%. But if we didn't conduct separation works, we had to dispose everything. So this orange part should be 100. So the separation works are really important. Okay, so I'd like to change the topic. So this is a second quiz about transport scheme for disaster waste. So I explained that disaster waste has to be removed from affected sites, and it has to be delivered into temporary storage sites for further separation works. And so this kind of transport scheme is necessary from damaged areas, affected sites, to temporary storage sites, TSS. And in the case of the 2011 Great East Japan earthquake, we prepared two different types of temporary storage sites, first temporary storage site and second storage site. So also between these temporary storage sites, we had to deliver those waste. And also after treatment, from TSS to treatment, utilization, or landfill. So these are our final destination of disaster waste. But when we consider this kind of transport, of course, we have to think how to deliver, how to transport those disaster waste. So I'd like to give you one very simple question. Okay, so let's assume this kind of waste. First one is wood pile. Pile means small mountain accumulated. So wood pile, concrete pile, metal pile, and soil pile. So, and let's assume that wood, the mass of wood was 200,000 tons, and concrete has 280,000 tons, and metal 110,000 tons, and soil of 300,000 tons. And then let's calculate the necessary number of dump trucks to deliver this waste. Okay, so how many 10-ton dump trucks do we need to deliver this waste? 10-ton dump truck means a dump truck which can carry 10 tons at one time.
Can
Okay.
I try?
Yes, please.
So if one dump truck can carry 10 ton, then we would have 20 plus 28 plus 11 plus 30. That would be 89,000 dump trucks,
Okay.
right?
Okay. Yeah. So, yeah, you mean this kind of calculation, right?
Right, yes.
Yes. So for 200,000 ton, it should be 20,000 cars and 28,000 cars, 11,000 cars, and 30,000 cars.
And then
So
we'll
in
sum it up.
total, yeah, the sum is 89,000 cars, right? Yes, but not correct. But not correct. Why? Why this calculation is not correct? Okay. Yeah, it's really bad question, and really tricky. And of course, we have to consider the loadable capacity, the capacity of a dump truck. And I explained that let's use 10-ton dump truck. So of course, it can carry 10 ton, but it also has a maximum volume. So it can carry only 7 cubic meter, only 7 cubic meter. So for example, if we fill this truck with water, with pure water, we can carry only 7 ton because water will overflow from the dump. So they cannot accept 10 ton. Although the capacity, the maximum load is 10 ton, the truck cannot hold 10 cubic meter. So when we calculate the necessary dump trucks, we also need to consider the specific gravity. Specific gravity is a little bit difficult, but specific gravity is a mass of unit volume. Unit volume means 1 cubic meter. So when we cut 1 meter, 1 meter, 1 meter, it should be 1 cubic meter. And the mass of the 1 cubic meter is a specific gravity, apparent specific gravity. So if we cut water with 1 cubic meter, it should be, of course, 1 ton. But when we deal with other waste, it should be different. So I give you some answers for these materials. Okay, so for example, when we cut this wood pile with 1 cubic meter, it should be just 0.4. So it's very light. It's very light. And concrete, I think you can imagine that concrete is very heavy. So it's larger. It's larger than wood, and it's larger than water. Water should have 1.0 ton per cubic meter. Okay, and metal. So metal itself is very heavy, but you could see that this kind of metal has various shapes, and it's not a solid metal. So it's very sharp, and there are a lot of voids, a lot of space between those metal wastes. So when we cut this metal pile with 1 cubic meter, it should not be very heavy. It's just 1.1. And soil, because small particles can become very dense, so it's heavy. It's heavier than concrete. So by using these values, we can calculate the mass of 7 cubic meter. So this 7 cubic meter is this acceptable volume of this dump. So let's multiply this 7 with this value. So we can calculate the mass of 7 cubic meter. So for wood, it's just 2.8 ton. So it's of course lower, smaller than 10 ton. So this dump truck can accept this 7 cubic meter. And yeah, the same calculation can be done for each material. And for soil, if we fill this dump truck only with soil, if we load 7 cubic meter of soil into this dump truck, the mass should be 10.5. So this is larger than this maximum load, right? So if we fill this dump truck only with soil, it cannot carry 7 cubic meter because over the maximum load of this dump truck. So in such a case, we can carry only 10 ton soil. Okay, so by using these values, can you recalculate necessary numbers of dump trucks? It's a little bit difficult. Okay, so yeah, I showed you these values, apparent specific gravity. So for wood, it has only 0.4. So by using this value, the volume of this 200,000 ton can be calculated as shown here. So with the weight, this is 200,000 ton, but when we calculate it into the volume, it has a different value, of course, and it has 500,000 cubic meter. So to carry this 500,000 cubic meter, by dividing this 500,000 with 7, so 500,000 divided by 7, this value can be obtained. And let's do the same calculation for each material. And for concrete, this concrete of 280,000 ton should be with the 200,000 cubic meter. So to carry this 200,000 cubic meters, we need this number of cars, dump trucks. And also for metal, we need these cars. But soil, I explained in a previous slide, and it cannot carry 7 cubic meter. It can accept only 10 ton. So that's why we need 30,000 cars. So in total, the answer is about 144,300 cars. So we can calculate this number by considering the volume of waste. So I think you can understand this value is large, very large compared to the first answer. First answer was obtained by only the mass of the waste. So when we calculate the necessary number of dump trucks, we also need to consider the waste volume. Okay, so yeah, this is a summary of today's my presentation. And the first one is Because landfills have a role of storing and separating disaster waste, enough space and capacity needs to be ensured from normal times. And the second one, to reduce waste disposed into landfills, separation needs to be done as much as possible using simple methods and machines. And necessary equipment for separation works need to be prepared from normal times. And for estimating the number of necessary dump trucks, apparent specific gravity, that means the volume needs to be also considered. That's all of my presentation. Thank you for your kind attention. Do you have any questions?
I think we have a question in the Q&A section. So you could.
Okay. I think. Oh, okay.
Okay, Sensei, we also have a question from Mr. Gadal. He asks, he says, thank you. What is the best technique for wet organic waste during the disaster?
Wet?
Wet organic waste during
Wet,
disaster. So
wet organic.
Yeah, I think maybe like wet wood or wet trees, something that is easy to rot, maybe.
Yeah, that's really difficult to answer. But basically, we try to leave the disaster waste in open air. And yeah, I didn't show you today, but when the disaster waste are wet, it's really difficult to separate because the soils of wet condition can act like it can bond various ways. So the best way may be adding some chemical agent to dry, but for a simpler method and a cheaper method, we just recommend you to dry in open air. Okay.
Thank you very much, Sensei. We have two more questions, one from Mr. Glenn Fernandez. So he asks, how can we incentivize local governments to maximize the amount of recyclable and reusable materials recovered from disaster waste? So in many developing countries, they just bring most of the disaster waste to the landfill. So how can we incentivize it to the local government so that we can recycle and reuse most of the disaster waste that we can recover?
Okay, thank you. Yeah, it's really important question and difficult question. And I think the same problems occurs also in Japan. And I was also asked what would be the incentive, what's a good point of using recycled materials. But my measure is soil, so I try to utilize soil in construction works. And we try to explain that utilizing this kind of recovered soil will reduce the amount of cutting new mountain. So it can preserve environment and yeah, but really difficult to give incentive for local municipalities. But I think the agreement of the national government and local municipalities to use such recovered materials need to be established before disasters.
We have one more question, Sensei.
Okay.
Thank you for your answer just now. So this is from Professor Gabriel. So he asks, good evening. I joined the lecture a little bit late, but I'm curious, how do you calculate the amount of waste when it is mixed? because, for example, after a disaster occurs, sometimes there's a mixture of concrete, metals, wood, etc. that can be found. So in such a state, how do we calculate? So that is his question.
Okay, thank you. I think on Tuesday it should be explained somehow. But I think there are various methods to estimate the amount of disaster waste. And one is to directly measure the mass. I think, I don't know how to say in English, but it should be called as truck scale. So by using the truck scale, the dump, we can measure the weight of the dump truck before entering the temporary storage site, for example. And after opening the dump truck, it can go to the same scale. And we can calculate the differences of the first weight and the second weight, and it should be the same amount of the waste disposed into the temporary storage site. It's a kind of direct measurement. And indirect measurement was conducted in 2011 because it's really difficult to measure the weight of truck immediately after disasters. So, oh, sorry, can you hear me? Sorry, okay. Yeah. So, yeah, after the disasters, it was difficult to manage the weight using the truck scale. So, without any attentions, sorry, my earphone is not good. Can you hear me? Okay, good. Thank you. Yeah, so yeah, in 2011, in a temporary storage site, some guys took a photo, and after taking photos, they extracted the this fraction is wood, this is metal, this is soil, etc. And after calculating the total mass is also really brief calculation, just visual measurement. It looks 5 meter or something, 5 meter, 10 meter or something. So by roughly calculating the volume of the pile, they extracted each fraction by hand. This is wood, this is soil, this is plastic. So the ratio of the entire pile should be like this. Yeah, but of course there are very large errors because it's not very accurate. So they recalculated many times.
We have a last question from one of the Kyoto University students. So,
Okay.
Gab, if you can ask Sensei the question that you were wondering about.
Hello, Sensei.
Yes.
Yes, thank you for your presentation. I have two questions. One is, how do we calculate the apparent specific gravity? Or we don't need to care about it described by literature? And the second question is, what kind of treatment is recommended for contaminated soils, especially soils contaminated by hazardous chemicals during the disaster waste?
Thank you. Thank you for your question. Yeah. This one. So this is just a typical value, and it's still very, very difficult to determine this apparent specific gravity of just one value. And some reports say that the apparent specific gravity of wood would be 0.2, or some guys may say 0.6. So there are really large variety of these values. So it's really difficult. But I showed you one typical value, one kind of average value of the values introduced in some papers. And about the second question, actually, it's difficult. It's impossible to utilize contaminated soil. Because of course there are many methods to purify the contaminated soil, but if it's available near the temporary storage sites, it may be possible. But basically, also in 2011 Great East Japan earthquake, contaminated soil was disposed into landfills, but the amount was not too much. Okay.
Thank you, Sensei. I think that's all for the questions today.
Okay.
We don't have anything more.
So should I close?
Okay, good job, everyone. At last, why don't you take a screenshot as a memory? Let's take photos. Is it okay? Okay, I count 3 count. Please smile and wave your hand, please. 3, 2, 1. Okay, thank you very much. ありがとうございます。
ありがとうございました。高井先生、ありがとうございました。Thank you very
はい
much, 高井先生。
ありがとうございます。Thank you very much.
Yeah, thank you very much,
ありがとうございます。
students.
ありがとうございます。